Most people completely missed it. On November 27, 2025, 3 Chinese astronauts returned to Earth carrying what looked like a trivial payload. Bricks. No breakthrough engine. No new spacecraft. Just bricks made from lunar soil. But when scientists opened the container, the implication was immediate and undeniable. After 1 full year exposed to vacuum, radiation, extreme temperature swings, and micrometeorite impacts, the bricks were intact. No cracks, no visible degradation. For the first time, a space agency had demonstrated that durable construction materials made from lunar soil can survive long-term exposure to space. This single result quietly shifts the moon from an exploration target to a construction site. Until now, lunar missions were about brief visits, scientific instruments, and symbolic milestones. This experiment points towards something different: permanent infrastructure built using local resources. China's approach to the moon reflects this shift clearly. It is not centered on a single landing or a headline moment, but on a structured, phased plan designed for long-term presence. The first phase is reconnaissance. China is already well into this stage. In 2024, the Chang'e 6 mission became the first ever to return samples from the far side of the moon. This region, permanently facing away from Earth, offers unique geological insights and strategic interest. The next step comes in 2026 with Chang'e 7. This mission includes an orbiter, a lander, a rover, and a small hopping robot capable of descending into permanently shadowed craters near the lunar South Pole. The focus on the South Pole is not accidental. Scientific data strongly suggests the presence of water ice in these shadowed regions. Water is a critical resource. It can be converted into oxygen for breathing and hydrogen for fuel. Access to water drastically reduces dependence on Earth-based resupply missions. From an engineering perspective, water marks the difference between a temporary outpost and a sustainable installation. The second phase of China's plan is construction. The brick experiment conducted aboard the Tiangong space station is a key component of this phase. 74 small bricks made from simulated lunar regolith were exposed for 12 months to conditions designed to replicate long-term lunar surface exposure. When the samples returned without damage, it provided engineers with real-world validation data. According to Professor Zhou Yang of Guangzhou University, these results allow researchers to model how lunar construction materials will behave over periods of 5, 10, or even 20 years. In 2028, China plans to extend this work with the Chang'e 8 mission. The objective is to manufacture construction materials directly on the moon. Autonomous robots will collect lunar soil, compress it into molds, and heat it at high temperatures to form solid structural blocks. These blocks can be produced in various shapes and assembled robotically, using automated systems to apply mortar and align structures. The process mirrors conventional construction, adapted for a fully autonomous extraterrestrial environment. Alongside brick-based construction, Chinese researchers are developing an alternative habitat concept known as the moon pot vessel. This structure uses an egg-inspired geometry and is produced using additive manufacturing techniques. It consists of an outer shell, an inner shell, and a triangular ribbed structure between them, providing both strength and pressure resistance. Unlike brick structures, these habitats can be pressurized directly, making them suitable for early habitation modules. The third phase is habitation. Between 2031 and 2035, China has scheduled 5 major lunar landings. Each mission fulfills a specific role. The first establishes command infrastructure, power generation, and communication systems. The second delivers scientific laboratories and exploration equipment. The third activates technologies for using local resources. The fourth expands robotic exploration and sample return. The fifth deploys astronomical instruments and Earth observation platforms. Together, these missions form the foundation of a permanent research station, energy supply, is one of the most challenging aspects of sustained lunar presence. Lunar nights last approximately 14 Earth days, during which solar power becomes unavailable and surface temperatures drop below minus 170 degrees Celsius. For this reason, nuclear energy plays a central role in China's plan. In May 2025, China and Russia signed an agreement to cooperate on the development of a nuclear power system for the Moon. Wu Weiren, chief designer of China's lunar program, stated that Russia holds a technical advantage in space-based nuclear systems. Rosatom, Russia's state nuclear corporation, already operates nuclear facilities in extreme environments, including floating reactors in the Arctic. A lunar reactor represents a logical extension of this expertise. The Moon offers certain advantages for nuclear systems. Reactors can be cooled by placing them in permanently shadowed areas with extremely low temperatures. Waste management challenges are also reduced in an environment without ecosystems and already exposed to high levels of cosmic radiation. The reactor is expected to become operational between 2033 and 2035, aligning with the transition toward permanent habitation. Another key aspect of lunar-based planning involves location. The lunar surface remains exposed to radiation, micrometeorite impacts, and extreme temperature variations. As a result, subsurface habitats are receiving increasing attention. The Moon contains extensive lava tubes formed by ancient volcanic activity. Some of these tunnels reach hundreds of meters in width and extend for many kilometers. They provide natural shielding from radiation and impacts, as well as relatively stable temperatures around minus 20 degrees Celsius. In July 2024, a study published in Nature provided strong evidence of accessible lava tubes beneath the Sea of Tranquility. Radar data revealed a subsurface tunnel extending well beyond the visible opening. More than 200 similar openings have been identified across the lunar surface. Chang'e 7 will carry ground-penetrating radar, specifically designed to map subsurface structures near the South Pole. Confirming accessible lava tubes in this region would significantly influence base design and long-term planning. While China advances according to a structured timeline, the United States continues to face delays in its Artemis program. Artemis 2, intended to send astronauts around the Moon, has been postponed until at least April 2026 due to technical issues with the Orion spacecraft. Artemis 3, the next planned lunar landing, is currently projected for 2027 or later. Budgetary constraints also shape the pace of progress. NASA's exploration budget represents a much smaller fraction of national spending than during the Apollo era. By contrast, China's space budget continues to increase steadily. The International Lunar Research Station project has already attracted multiple international partners, with plans to expand collaboration further. What is unfolding on the Moon is not a sudden race, but a gradual transformation. Space exploration is evolving into space infrastructure development. The focus is shifting from short missions to long-term systems, from temporary visits to sustained presence. The Moon is becoming a proving ground for how humanity may live and work beyond Earth. And the groundwork for that future is being laid right now. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.